Alright, so in the last video I showed you how to derive the law of sines. So I'll just go ahead and remind you what that is. So that we found that the sine of A divided by its opposite side A is equal to the sine of B divided by its opposite side B, which is equal to the sine of C divided by its opposite side C. So I'm going to start off with a problem, and this is a very specific problem. It's going to be a ASA problem, basically given two angles and a side. This is a non-right triangle with a given angle of 118, 22 degrees, and a side of 24. And I'll go ahead and label. I'll just go ahead and label this exactly how I labeled it in the last video. A, B, C, opposite side C, opposite side A, opposite side B. It doesn't actually matter how you label this as long as you just make sure your sides are opposite of the angles they represent. Alright, so from the way that I labeled, looking at my ratios, the sine of B is the sine of 118 and its opposite side B. We don't know B. We don't know A's opposite side. Or sorry, we don't know the opposite angle for A, and we don't know the opposite side for C. But we do know a relation about angles inside of a triangle, and the fact that angle A plus angle B plus angle C should equal 180. So what that tells me is that 118 plus 22 plus A should be 180, thus A must be 40 degrees. So you would have found that by taking 180, subtracting 118, subtracting 22 from that to get 40 degrees. Alright, so now we do have a relation to its angle and its opposite side. And we can go ahead and set as the law of sines. So the sine of 40 divided by the opposite side is equal to, and it just kind of depends on what we want to solve for first. I'm going to use the sine of 118 and solve for little b first, and then we can solve for little c after that. Alright, so this is basically two ratios set equal to each other. So the way we solve two ratios set equal to each other is by cross multiplying. So this tells me that b sine of 40 is equal to 24 sine of 118. Dividing by the sine of 40 on both sides, so we can get b by itself. We give me b is equal to 24 sine of 118 divided by the sine of 40, which approximately equals 32.9669. Alright, so again, to find letter C, we're going to do the same thing. We're going to use, a ratio that we know and set it equal to the sine of C over C. Now, as far as which ratio that we should use, we actually now have two. We have 40 degrees and 24, and we have 118 and 32.9669. I'm going to go ahead and still use the 40 and 24 because I know those are exact values. This 32.9669 is an approximation. It's, we had to round it a little bit. And so if we use a rounded number in the beginning, it's going to give an even more inaccurate version of C. So let me go ahead and start off with the one that we know the exact numbers for. So the sine of 40 degrees again divided by 24 is equal to the sine of 22, sine of C, divided by little c. So we'll do it by the same process, cross multiplication. So c sine of 40 is equal to 24 sine of 22. To get c by itself, we'll need to divide by the sine of 40. So thus, c is equal to 24 sine of 22 divided by the sine of 40, which again, approximately, we're rounding here, approximately is equal to 13.986. So 13.986. And now we have solved the entire triangle. We know all three angles and all three sides. So this was the law of sines case of ASA, angle, side, angle.